Hello there everyone. This is one of the Back to Basics series of physics tutorials, this time focusing on relative velocity. How does addition of vectors help in analyzing relative velocities? To find out, just hang on, watch and learn. Question number 1. An airplane's compass indicates that it is headed due south, and its airspeed indicator shows that it is moving through the air at 250 kilometers per hour. If there is a 120 kilometer per hour wind from east to west, what is the magnitude and direction of the velocity of the airplane relative to the Earth? This problem involves velocities in two dimensions, okay, southward and westward. So it is a relative velocity problem using vectors. All right, we are given the magnitude and direction of the velocity of the plane relative to the air. This is represented by the vector arrow colored red. Right? So we say that uh, the vector b sub pa is equal to 250 kilometers per hour due south. We are also given the magnitude and direction of the wind velocity, all right, which is the velocity of the air with respect to the Earth. And this is represented by the blue vector arrow in the diagram. And that is, B sub AE is just equal to 120 kilometers per hour due west, right? Applying the rule in adding vectors, okay, connected head to tail, okay, head to tail. In other words, the first vector or the second vector is connected from the head of the first vector. Okay? And the direction of the resultant vector, represented here by uh, the vector arrow colored brown, notice that it is connected from the tail of the first vector to the head of the second vector. Alright? And its direction, alright, the direction of the resultant vector b sub pe, alright, is represented here by the angle theta. Alright? Angle theta is the angle measured from uh, the south geographic direction. Alright? In terms of degrees, how many degrees is the resultant vector b sub pe? Alright? From vector b sub pa. So that is the meaning of angle theta. And to find the magnitude of the resultant velocity of the airplane relative to the Earth, all right, that's our target variable, b sub pe, we just use uh, our formula for vector addition, all right, b sub pe, or vector b sub pe is just equal to the vector b sub pa plus the vector b sub ae. And applying our concept on trigonometry, since the three vectors, when connected like this, as shown in this diagram, they form a right triangle, right? The right triangle, where it appears that the resultant vector b sub pe, okay, becomes the hypotenuse of the right triangle, the vector b sub AE becomes the opposite side of the angle theta, and v sub PA is the adjacent side of the right triangle. So, determining the magnitude of the vector b sub PE, or the speed of the airplane relative to the Earth, we just use the Pythagorean formula, right? So b sub PE is just equal to the square root of the square of the magnitude of b sub PA, which is 250 kilometers per hour, and the square of the magnitude of the velocity vector b sub AE, which is 120 kilometers per hour. In doing our math, we will get magnitude of b sub PE equal to 277 kilometers per hour. So this is the speed of the airplane relative to the Earth in the diagram that is represented by the brown colored vector arrow. Right? And how do we determine the angle theta? So again, using our trigonometric formula for determining the angle theta, we just use the arctan of the opposite side divided by the adjacent side. So the opposite side is equivalent to 120 kilometers per hour. That is divided by the adjacent side, equivalent to 250 kilometers per hour. Again, using your scientific calculator, we will get the value of the angle theta equal to 26 degrees. So we say that the velocity v sub PE, all right, or the velocity of the airplane relative to the Earth is equal to 277 kilometers per hour, directed 26 degrees west of south. All right, west of south because we said that the angle theta is the angle measured from the reference axis. In this case, the reference is the south geographic axis. All right, and we are describing the direction of the hypotenuse, or the what you call this, the velocity of the plane relative to the Earth, right? So since this vector is to the left of the red vector, that is described as west of south, all right? And west of south, if you wish, can also be described as southwest. So we can also say that the direction of the velocity of the plane relative to the Earth is 20 degrees southwest. Okay? Question number 2. Letter A. With wind and air speed given in question number 1, in what direction should the pilot head to travel due south? Question letter B. What will be his velocity relative to the Earth? The figure is a scale drawing of the situation. Again, the vectors add in accordance with our equation and form a right triangle. As the diagram shows, the pilot points the nose of the airplane into the wind to compensate for the crosswind. All right? the angle beta, okay, which is one of the unknown variables, all right, this angle tells us the direction of the vector b of PA, all right, b of PA whose magnitude is given as 250 kilometers per hour, but the angle or the direction is still to be determined, and that is represented by the angle beta. All right. Um, so beta is one of our target variables, and the other target variable is b of PE, right? The speed of the airplane over the ground, all right? In the diagram, that is represented by this brown vector arrow, all right? Its direction is, of course, due south, all right? The other, all right, or the known and unknown quantities, just to summarize, we have uh, the velocity of, or the magnitude of the velocity of the airplane, all right, relative to the air, that's the one in red, equal to 250 kilometers per hour. And then we have, of course, the given velocity of the wind, all right, still 120 kilometers per hour due west. And um, our, what we call vector formula for determining uh, velocity BPE, all right, is just shown in this equation, all right. Vector BPE is just equal to the vector sum of BPA plus V sub AE, right? And again, we can determine uh, the magnitude of BPE, okay, using trigonometry and uh, the diagram here, which shows that the three vectors are already connected head to tail, and they form a right triangle. All right. So, using the Pythagorean formula, we calculate for the magnitude of BPE, and that is equal to the square root of 250 kilometers per hour. All right. That's the magnitude of B sub PA. That's to be squared minus, all right, the square of the magnitude of B sub AE equal to 120 kilometers per hour, all right? The reason why it is minus and not plus, because you will notice that in the diagram, uh, the, uh, the vector arrow representing B sub PA happens to be the hypotenuse, all right? The longest side of the right triangle. And V sub AE, okay, the vector arrow in blue happens to be the opposite side of the angle beta. And of course, the arrow representing V sub PE, okay, happens to be the adjacent side, right? The one we are calculating. And so therefore, uh, based on Pythagorean formula, okay, if you want to determine the adjacent side, all right, given the opposite side and the hypotenuse, okay, we simply get the square root of the square of the hypotenuse minus the square of the opposite side. All right. So this is in accordance with our trigonometric rule in determining one side, this in this case, the adjacent side of the right triangle. All right. So using our math again, we will get the magnitude of B sub PE, or uh, the speed of the airplane relative to the Earth. We call this the ground speed. And that is equal to 219 kilometers per hour. All right? So the other unknown variable, of course, is the angle beta. So using again the definition of arctan, all right, arctangent of the opposite side divided by the adjacent side, since we know already the value of B sub PE, all right, 219 kilometers per hour. So with the help again of your scientific calculator, we'll be able to determine the angle beta, which is 29 degrees. Okay? So, in short, the answer to question letter A is angle beta equals 29 degrees east of south. All right? In the drawing, uh, we have indicated here that angle beta is the angle measured from the south axis. All right? How far is the red arrow in terms of degrees from the south axis, or the what you call the south geographic axis, represented by uh, the vector b of PE, right? That's why it's called east of south, which can also be, if you want, that can also be described as 29 degrees southeast, right? 29 degrees southeast is just the same as 29 degrees east of south. And of course, our answer to question letter B, okay? Question letter B, what is the magnitude, all right, of the ground speed, which you already have determined to be 219 kilometers per hour. And so our final description of the ground speed of the plane, we say it is flying at a magnitude of 219 kilometers per hour due south. Right? So that completes our answers to this problem. Thank you very much for your indulgence. Till our next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.